We looked at zonal mean meridional vertical sections of zonal and meridional winds, and we looked at maps of surface winds. Obviously, we need to complete the story by looking at maps of upper level winds. 200 hectopascal is the typical upper level surface we look at. So we are again looking at the seasons here, solstitial and equinoctial, and the bold blue line here separates the easterlies and the westerlies, and they are written here as easterlies and westerlies. As I said, westerlies are going from west to east, easterlies go from east to west, and at the surface you have trade winds, southeasterlies, northeasterlies, and then mid-latitude westerlies, which I probably didn't emphasize enough before. In case I didn't do that, you can see here westerlies that remain pretty strong throughout the year, and then there are the waxing and waning of the subpolar sea level pressure center as well. That corresponds to the winter deepening of the low and the associated storm tracks and rainfall and so on. Okay. Which is not very obvious here, but you can see that this is summer, winter, much more rain at the mid-latitudes. So at the upper level also you have westerlies, westerlies in mid-latitudes, as we saw with the vertical shear. So the jet stream is going to be here, and you can see this rather strong westerly wind blowing across. And there is a scale shown in each of these figures which may be missing here, but nonetheless should be somewhere. You can look in the book. The low latitudes, you can see that the boundary between the easterlies and the westerlies is seasonal dependent, as you can imagine. So you have monsoonal circulation over the Indian Ocean, creating a separate seasonality or a distinct seasonality compared to the tropical Pacific and the tropical Atlantic, with the ITCZ still clearly seen here. So these are doldrums and so on, where they are westerly. Peter calls them westerly ducts. I think this is the common terminology, but he may have introduced it early on in the 1980s during his PhD years, I suspect. Basically, that's where the interhemispheric exchanges can happen as well. And remember, this is in the upper level. We are not talking about the surface. So you have different directions in the tropics compared to the mid-latitudes. Mid-latitudes, westerlies all the way from the surface to the upper level with a vertical shear, so westerlies getting stronger with height, whereas in the low latitudes you have northeasterlies and southeasterlies here, but in the upper level you have easterlies here, the westerly duct, and you have easterlies here over the Indian Ocean as well, depending on the season. So you have strong easterly jet here in the summer monsoon season. So the southwesterly winds in the lower levels are associated with these easterlies in the upper level, whereas in the winter the westerlies come way down into the low latitudes or the Indian region. So this is what channels in various winter weathers from all the way over the Mediterranean and Atlantic into the Himalayan and Indian regions. And of course there is a transition during the equinoctial seasons happening as well. Okay, so in general, when you think about sea surface temperatures that go with it, this Indo-Pacific warm pool will have low wind speeds, low latent heat loss in the mean. Of course, there can be high frequency winds like westerly winds, wind bursts and easterly wind bursts and so on. In the upper level also you see that there is a seasonality and there is not such a strong steadiness that we see in the westerly bands. Okay. those are some of the points one could take from these. It'll make more sense when we look at the vertical and zonal and meridional circulations. The other critical thing we have to worry about in the atmosphere is the moisture flux. This is the main way in which energy gets moved from low latitudes to high latitudes. And this is how it is defined. So the humidity flux or moisture flux in X and Y is determined by integrating the moisture and its advection term by the winds from the surface to the top of the atmosphere. Top of the atmosphere is basically where pressure goes to zero. Okay, so this is the mean specific humidity as a function of latitude, longitude, and height, and this is the wind vector also as a function of latitude, longitude, and height. So this is the mean because we have integrated out the time. Remember, this is already integrated out the time here. Okay, so QV and V tilde represent the distribution of the time average specific humidity and horizontal velocity within a column respectively, and TOA is the top of the atmosphere. So looking at the moisture fluxes, this is now vertically integrated moisture flux. When we say moisture flux, it is the advection term, V times Q. Okay, it's how winds are transporting the moisture, and you look at it vertically integrated. As we saw, specific humidity is high near the surface and drops off quickly with height, but winds can get stronger with height, so you have to be careful about how the flux is balanced. Okay, so for looking at June, July, August, and December, January, February, focused here on the Indian sector, you can see in the summer there is very strong vertically integrated moisture flux coming into the Indian subcontinent and around the Indian peninsula over into the Bay of Bengal, which has high amounts of rain as well. And of course there is a convergence into the Gulf of Mexico, which is very warm here as well, and you can see the South Atlantic convergence zone. So the ITCZ runs through here, and you can see the kind of the trade wind pattern that's fluxing moisture towards the west, which is the warm pool region here. Remember, the sun is to the north, so the warm waters are to the north here. There is circulation and rainfall over the maritime continent. A lot of moisture being picked up from the southern tropics across the equator into the Indian subcontinent, whereas in the winter monsoon months you are going from the again the flux going over the warm pool region over to the maritime continent, and circulation changes over the maritime continents is obvious here as well. You can see complete reversal of the moisture flux here from the summer months to the winter months, and the same over the African continent. Okay, again, just try to remember these features, but you can see a more steady westerly flux here in the Southern Ocean. As you get beyond the continents, you are still in the subpolar front, but you are getting into the Southern Ocean here. So you can see the steady westerlies creating the steady westerly moisture flux here, whereas there is strong seasonality in the lower latitudes in terms of the moisture flux. Okay, just stare at those figures often enough, and having that in mind will help you when we start looking at the dynamics of the atmosphere, air-sea interactions, and the moisture fluxes, along with the Hadley circulation, the Walker circulation, and so on.